Hi, Squish. I know. Alright, you're gonna be in the video. I don't care. Hey, I'm Evan, and I'm a developer for a Zeek project. Today I'll be showing you can use Zeek scripting in order to customize Zeek. Scripting is how you can make your own Zeek logs or customize existing logs, so it's pretty powerful. It's also necessary to customize scripts that Zeek and third-party packages you might install provide. By the end, we'll be able to understand a full Zeek script. So let's get started. I'll mostly be going over the new scripting tutorial that we're working on in Zeek documentation, but I'll also include other interesting tidbits here and there when they make sense. First, you're going to need a working Zeek install. There are various packages for whatever operating system you're running. You can see our install guide for how to get that set up. But you can even use a Docker image if you want, with docker pull zeek/zeek:\latest. And I'll pull in the latest Zeek Docker image, but I already have it, so it does nothing. You can edit Zeek scripts in a variety of different editors, including VS Code. I'll be using Helix with the Zeek language server setup, but feel free to use whatever you're most comfortable with. You can make sure everything's working by running Zeek on a small hello world test script. So here I have test.zeek. It just has event Zeek init, open brace, print hello world, and a semicolon, and close brace. If you run that with Zeek test.zeek, you should see hello world. Now, let's get started. So, why do we write Zeek scripts? One common reason would be to load and customize other scripts. If you're running a Zeek cluster, you'll have a local.zeek file that gets loaded in your cluster. If you want to load scripts in a cluster, you add it to that. Also, if you want to customize load scripts options, you use that file. Even if you don't write a single script in your life, knowing how to customize them is useful for your own Zeek cluster. Scripting is also the core of a detection. You can write custom programs that react to network traffic and fire notices when a certain CVE or whatever else you care about is detected. That's what we'll be looking at here, a malware registry. Say we want to see if known malware is downloaded on our network. So we can use the file's contents in order to compute a hash, and then we compare that against known malware. If it is known malware downloaded on your network, it can be an issue. So Zeek comes with a policy script called detect MHR that uses a malware hash registry and triggers a notice if malware is detected. We'll see it I'm in the Zeek tree right now, and I can open it up. So policy, frameworks, files, detect MHR. And this is the actual script that Zeek ships with, right? Top of this file is a bunch of loads, module exports. We won't go over all of this right now. For now, we're just going to look at this file hash event. By the end, we're going to understand the full script though. So this event, file hash, is fired whenever Zeek computes a hash for a file. And so we can look at that hash and we can say, hey, is it in this known malware hash registry? And if it is, we fire a notice. So that's just a flavor of how Zeek scripting works, but let's get into weeds with types. All right, Zeek is a network monitor, so Zeek has network types. You have types for addresses, like IP addresses. It's spelled ADDR in Zeek. You can use subnets for subnets and port for ports. So you can specify a network address, just local my address, specify its type as ADDR, equals like 192.168.1.100. Right, that's a network address. You can do IPv6 as well. My IPv6 address is the same type, but then just use square brackets with colon-separated hexadecimal form. You can also test if they're equal. So you could say if my adder equals my IPv6 adder, right? And then print equal. If we exit out of this, Zeek test.zeek, we actually see that they're equal, right? In this case, Zeek treats IPv4 and IPv6 as the same type. So an IPv4 mapped IPv6 address, like we saw in this test.zeek file, it's just treated like an IPv4 address. You can also use subnet. Local my subnet is a subnet, and say it's 192.168.0.16, right? Then you can see if my address is within this subnet. So my adder in my subnet. and if they are, we'll just print it's in the subnet. Easy. You can also specify ports. It's just an unsigned integer followed by the transport protocol, like local my port equals 443 TCP. Okay, then after you have a port, you can do simple things like compare it. So you could say if my port equals 443 TCP, that's a double equals here. This is probably HTTPS, right? Make sure if you're testing for equality, use 2 equal signs. If you're assigning, use 1 equal sign. So we can go out and we can run this script, and we see the addresses were equal. My address was within my subnet, and that port is probably HTTPS. Zeek uses these types to identify a connection, so they're pretty important types. Notably, Zeek's 5-tuple uses address and port pairs alongside the protocol to identify a connection. Next, we'll go on to other unique types that Zeek has, like time types. Network traffic happens over time, so Zeek has time types. These come in 2 main flavors. You have the time type and you have an interval type. Really, time is simple. It's just some absolute point in time, or epoch time as you would describe it. You can't specify it directly, so we're going to grab it from the current time BIF. Okay, so you can grab the current time with local my time. It's a time type equals current time. You can then add an interval to the time. We'll see intervals in a second. So my time 2, also a time type. You take my time and add 1 second. You also have like minute. You have other options for intervals. Then you can get the interval between 2 types. So like local interval between these 2 is my time 2 minus my time. So subtracting 2 times gets you an interval. And we can also see that. Then we can also take this interval and add another interval to it. So we'll take basically the times that we have executed the script so far. So current time minus the first time that we got at the top here. Then we can print this, so print interval between, and we can exit Zeek test.zeek. Zeek test.zeek, and it's 1 second and a little bit. All right, so now we can specify like a timeout interval. So let's say my timeout interval is a second. And then if the interval between the 2 calls was greater than the timeout interval, then we print timeout. In Zeek test.zeek, and we see it timed out. So intervals are useful for a lot. You can schedule events to happen sometime in the future with the schedule keyword, or you can cause values to expire with the create expire attribute. Here we were actually using current time, which is a BIF. What you'll probably do is use network time. It's a different BIF that will take the time of the last packet. Current time gets you the wall clock time. All right, so next we're going to go over some of Zeek's more standard types that you can expect from any programming language rather than these esoteric types. All right, so Zeek has a few types that contain other types, namely vector, set, and table. So vectors are used to store sequential data in order. The elements in a vector don't have to be unique. You can consider it just a list of addresses that you have in order of priority. Say you have a list of IP addresses, like mail server IPs. It's a vector of addresses. And then we specify a vector with a vector word in parentheses, then 10.0.0.1 and 10.0.0.2. You can then add elements with plus equals. So server IPs plus equals 10.2.2.3. You can even loop through a vector. So this for loop is a little weird. This first element is this first part is actually an underscore. This underscore would be the index of the element. So for here, we don't care about the index, so we just set it blank. And then we have the server IP within the body of this loop. Okay, you can also get the size of a vector. You can get that by using, like absolute value, the vertical bars. So print format, there are %d IPs, right? And then vertical bar, mail server IPs, vertical bar. If we go out, Zeek test.zeek, then you see 10.1. 10.0.0.1, 2, and 3 are mail server IPs, and there are 3 of them. Vectors are great for ordered elements. If you mostly care about checking if something is in a big list, then sets might be better. So here we have Zeek in it. You can make a set by just saying local safe ports is a set of ports. And we say set is 80 TCP, 443 TCP, 53 UDP. Doesn't really matter. You can check to see if something is within that set by saying if 22 TCP is in safe ports. Then we can print a format string. Is a safe port. And we'll say 22 TCP. Else we say it's not a safe port. So if we go out and run this, we see 22 TCP is not a safe port. You can add elements to a set, the add keyword. So add safe ports, 22 TCP. And you can see now 22 TCP is a safe port. Deleting is the same thing, but with the delete keyword. So now it's not a safe port again, because we just added and deleted it. You can also loop through elements of a vector with for. So for a safe port in safe ports. And let's just print format string. This is a safe port. Safe port. So here we just loop through all of the ports. We say that they're a safe port, and we end. So Zeek test.zeek. And we can see that it prints all of our safe ports. Now, one caveat to this is each time I write, it's going to give me a different ordering through the loop. So as you can see, like at the top here, 443 TCP was first, but here it's second. Sets by default are not ordered, so every time you run this, it's going to be different. You can change that though. So if we want to make this ordered, we have to add an ordered attribute. So we add it like that, and now we can't declare it in the same way. So now we have to add each port individually, with like add safe ports, and then we have all of the ones that we just had before, right? So we had 80 TCP, we had add safe ports 443 TCP, and then 53 UDP. Now if we run this, it's the same exact order each time, and it's the order that we added them in. So here we use the ordered attribute. Attributes are just these things with ampersand before them, followed by some word. In this case, it makes the set ordered based on whenever we added the port. All right, then there's one more thing. You can use tables. So a table is just a mapping of key value pairs, right? So let's say we want to have names of different IP addresses. So local asset names, table of addresses of string. So that means address is my key type and string is my value type. And I start the table and close it. and then the keys are surrounded by square brackets. .1.1 equals router. And then like 8.8.8.8 is the Google DNS, so Google DNS. So now we have a table that you can look up, like asset names 192.168.1.1. You can say print that, and that should print router. All right. You can also add elements. So asset names 1111, that's Cloudflare DNS. Cool. And then you can also just loop through every element. So for known address, name in asset names. Here we're going to use curly braces and print format. Address %s is %s. Known address name. So this should loop through the entire table and print every element in key value pairs. So the first before the comma is the key, the second is the value, and it's is available within this for block. All right, and then we run this, and it just prints what's within the table. Now this has the same problem with sets. So this is going to be different every single time I run it. I guess the first two are the same, but after that it's different. If you need tables to be ordered so that this looping is deterministic, then use the ordered attribute. So that's how you'll work with loose sets of data. Next, we'll go over how you can use records to your advantage to actually name fields if you need that. Zeek also provides you types called records, or like a struct in C. You provide a group of name variables and you put them all in one place to pass their events and whatnot. The most used record is connection. This is a Zeek type which holds a state for a given connection, hence its name. Zeek script uses the $sign to get variables from the record. So I'll show you, I'll remove test.zeek and show you a new test.zeek where we go in the new connection event, because this gives me a connection record. We'll make two variables within this. So originator host, this is an adder, and it's within the ID field of connection. And within that, we have origh, which is originator host. Same thing for responder. It's just this ends up being resp, and then this ends up being responder. So here we are accessing the connection records ID field, and within that ID field, we're accessing these origh and resp h. So then we can print something about this, found connection %s, and just some arrows %s. Originator host, responder host. Then we can go out. If we just run this as is, we actually have no connections, so it's going to do nothing. But we can say zeek test.zeek and provide a pcap file. I'm going to use the one from documentation. So I have it here in doc traces quick start, and it says found connection between these things. So some analyzers add their own fields to a connection record, like HTTP. If they do, the add fields have to be either optional or have a default, but normally they're optional. You can test to see if a record has the optional field with $$sign. Now, once we have this big event signature ran out, we can check to see the connection record. So see HTTP. So this is asking, does it contain the HTTP field? And then here, see HTTP. We're assuming it has it at this point. Does this contain the URI field? Then, if it does, print found HTTP URI %s. So see HTTP URI. You'll use this a lot, right? So here we're checking to see if a connection record has the HTTP element or field. And then here we see if that HTTP field has the URI field. So we can run this again on the quick start pcap, and both of them just go to the slash index. And if you want, you can also make your own record. So type asset is a record, and you can add whatever fields you want, like IP is an adder, owner is a string. Make sure you have semicolons after each, and then initialize them with name fields. So Zeek init. So my asset. You initialize it with just the name of it, and open parentheses, close parentheses. And then you can set each field like $IB, 192.168.150, and then $owner equals Evan, because I'm Evan. Print my asset. And then Zeek test.zeek. That's how it prints out. Okay, so finally, there are often a bunch of types that you'll find in any language. Zeek has its own signed integer type in int, so you can assign that to like -5. It has an unsigned type that's a count equals 10. So print format I+5 equal %d and I+5. So that'll print 0, right? Zeek test.zeek. Cool. So one other important type is patterns. You can say local good words equals good or great or amazing. These are just regular expressions. You can print good words in some phrase that contains it, like this is good. So this will print true, because good words, this actually has good, right? So Zeek test.zeek, and it prints T for true. So these types are the building blocks of Zeek. So now let's learn a bit more about how packages expose values using these types for you to change and configure. Okay, so instead of just configuring everything with local values, that's what the local keyword we've seen is, many scripts want you to be able to change their values. Like if there's a timeout, you probably want to let users change that timeout to fit their particular needs. Zeek does that by exporting variables. So the primary way that this will work is with options. So here we're going to create a module called test and export option my timeout. So it's an interval and it equals 10 seconds. Now options have to have a default value, that's what this 10 seconds is. But then you can later redefine them in scripts with the configuration framework. So here let's just print it. Print my timeout. If we just run this as is, we will see 10 seconds. But we can then create some other script like test2.zeek. And here we could say redef test my timeout equals 30 seconds. Then if we run Zeek test.zeek, test2.zeek, so we load both, we can see it's actually 30 seconds instead of 10. Normally this redef here is going to be in your cluster's local.zeek file. So your local.zeek can redef whatever variables it needs in order to function. Now you can also use export and redef with a lot more. So a primary use is with the connection record, you can actually change what goes into it. So here we're going to say we have a deny list. We export some deny lists that we care about. Say it's a constant, and it's a set of addresses. Set 192.168.1.8. That's just default value, it could be an empty set. Then we redefine the connection record, plus equals, and we add a denied boolean with the default to false. Now we go into new connection event, and we can set this denied field based on what we see. So see denied equals, we check the originator in deny list, or if we have the responder in deny list. And we'll just print the denied record within the connection for now. So Zeek test.zeek, this will do nothing because we have no network data, so let's load the quick start PCAP. So if we do this, we see both were denied. Now you can do something similar if you want logged instead. this connection record is what actually gets passed around within a connection, but something else gets logged, and that's con info. That is what actually gets logged when you see con.log. Then we can say, okay, this denied field, we add the analog attribute. This means that we want it to be logged. And in each case that we see C denied, we actually need to do C con denied. So this is the connection records con info member. And we don't need this print anymore because it's going to get logged. All right, remove all of the logs and then run Zeek on the quick start pcap. Then we can cat con log. It's kind of hard to see as is, but the last one for each of these is true. We can pipe this into Zeek cut and just get a denied field. And you can see that both are true. So this entire time we've seen one of Zeek's core concepts, but haven't really touched on much, and that's events. So let's get into that. So Zeek is unique in that its scripting language is event-based. Something happens on your network and Zeek triggers an event for it. Even Zeek's core utilizes these events in order to accumulate information about a connection. Let's see a bit about how they work. An event can be triggered from a variety of places, and when it's triggered, it doesn't get immediately run. It's put into an event queue. You, the user, define handlers for these events. So let's just make a simple handler for Zeek init, one of the many events that we've seen so far. And let's just say print hello world. This is the same hello world example as from the beginning, and so we can write and see it prints hello world. But we can also define two. So we can say event Zeek init and then print hello again world. If you run this, then you'll see both get run in order. But this ordering just is up in the air. You shouldn't rely on it. You can instead use Zeek's priority attribute and set this one to a higher priority if you want to run first. So now the order flips. Events are all over the place. We already saw like HTTP requests, we saw new connection, but there are many others for DNS requests or file hash, as we saw in the very first script, or whatever you're interested in tracking for whatever protocol. But you can also make your own events. So here I'm going to define my custom event. Takes in a number, and with that, we can print the number. So my custom event got %d, a number. So that's going to print, and we can run this on Zeek init. You run events with the event keyword. This creates an event statement. So my custom event 5. If we run this, we can see our custom event gets run. So what happens if you print after it? This print actually gets run first, and that's because this event gets added to an event queue, but it's not run immediately. So if we run this, zeek test.zeek, it says after first. This is just a consequence of every event getting placed into an event queue, but it will finish handling your current event first. Functions are similar, but they can return a value. So we can have function 1, this returns a count, and it just returns a number 1. Then event Zeek init, local my1 is a count, and it equals the result of the function call. And if we print this, then we'll see it prints 1. Now, what if we want a function to actually add 1? So we change this to add 1. We take in some value x and say it's a count, and we don't return anything. Then we just say x equals x plus 1. This will not add x in the way that you might expect. So let's just say local x equals 5, add 1 x, and then print x. Here, this will actually print 5. So it does not, x equals x plus 1 does not persist into the caller. The reason is this actually gets copied. And the only types that are passed by reference, that means that the function that is called can modify it, are containers. That means that it contains multiple types. One of those is a record. If we want to modify the type, we can instead create a type X, which is a record, and just have it have an inner count. Then here, add1 should take an X instead of a count. And here we just modify inner instead. So then we use local X is an X, and we set inner to 5, and now we want to print X inner. So does this print 5 or 6? It does print 6. So if you have, the rule of thumb for this is if a type is a container, that means it holds other types, then you can modify its contents. If it's atomic, like a count, you can't. So if you have doubts, just try it like I'm showing here. With that, we have everything that we need to know in order to return to the detect MHR script. All right, now we can return to a script that we saw at the beginning. So I'm going to skip this first section and go straight to the end where we have this file hash event handler. So file hash is called whenever Zeek computes a file hash, as you can imagine. And then in here we have an if check just to make sure that it's something that we care about, like it's a SHA-1 hash and we have the file info, etc. And then we call this do MHR lookup function. Do MHR lookup takes in a hash and this notice file info that's useful for the notice later. Here we construct a hash domain with a format string, so %s taking in a string, and that string is a hash. Then we look up the host name. This is done in a when block, as he calls it. Thanks, Squish. Then we look up the host name. This is done with the when keyword because looking up the host name is going to take a bit of time. So this is asynchronous. Here it actually takes in a few what are called captures. And so this hash variable, fi, and hash domain are all going to be available within this when block, which we'll look at. Then within this block, we have this MHR answer. So this is just taking a result and splitting it at a space. So then if we have two elements, so we have the date first detected and detection rate, so it's what we expect. You see these vertical bars are the size of this vector. Then we take the detect rate, that's the second part, so it's the first index because they start at 0. And we convert it to a count. If that detection rate is above some threshold that we set, then we want to fire a notice. All of this part is just making the notice pretty. So we get the actual time type rather than just a double. We format that time type, and then we create a string with that time type and with other stuff in it. And at the end here, we actually file the notice. So this is how you would tell incident responders or whomever else that we care about this thing and we detected it. So the parts at the top of this file, so this notice threshold here is actually an option. So we saw options throughout, so this is how you would configure the script to your liking. So if you want the notice threshold to be 50 or 5, you can change that yourself. So the same thing applies for like this match sub URL and this match file types. You can change these to be whatever you want within your local.zeek file of your cluster. So this redef enum notice type here, this is actually part of the notice framework. So this is actually what lets you run through, and it lets you make this match notice, which you can see goes in here. So that's all part of the notice framework. It's not necessarily just native Zeek scripting. And that's it. Hopefully this script was simple enough. It's a pretty standard script that you'll see throughout Zeek. We'll have Zeek's many policy scripts that you can load in your local.zeek file.